This lesson in pre-cal is about circles and ellipses. We've actually talked about circles earlier on in the year, but this is one of the things that's important for your other math classes that you will encounter, so we're just going to kind of review those things. Starting with part A about circles, and that is that the general formula is x squared plus y squared equals r squared, with center 0, 0. And r, of course, is the radius. Looks like I'm out of focus. Hold on. Let's bring that back. Okay, if I have a different center, then I'm going to do x minus h squared plus y minus k squared equals r squared, with center hk. Now notice here that my center hk is here and here, so the signs are opposite of what you see here because naturally they're negative. So if it's h and k, if it's negative, it's opposite. If it's positive, it'd be negative. So watch out for that. Let's look at some examples. Number 1. If I want you to write the equation for a circle with center -5, 3, and radius 3. And then I want you to sketch it as well. Okay, so starting with plugging it into the formula, this would be my h, this would be my k. So I'm going to do x minus h, which is -5, so that becomes positive, squared, plus y minus k, which is 3, and that stays negative, equals the radius, which is 3, squared. The next thing I want to do is go ahead and square my radius, and that is 9. And so this is my equation for my circle, and I just leave it like that. If I want to sketch it, just going to go 5 each way to start with. Go ahead and plot your center, which is at -5 and 3, and then make your center go out 3 each way. So if I do that, I'm going to do 1, 2, 3 this way, 1, 2, 3 this way, 1, 2, 3 this way, and 1, 2, 3 this way, and then just connect my circle. And there's a sketch. Again, the radius needs to be 3. The center needs to be where the center starts. Example 2 on circles. I want you to graph x squared plus y squared equals 4 in your calculator. And you should notice here that there's nothing being multiplied by x or y, so there's nothing inside of a parenthesis, so the center is 0, 0. To be able to graph something in my calculator, I want to get it to where it says y equals, because there's no way to type in y. So if I do that with this, I'm going to start by subtracting x squared from both sides. And then I'll have y squared equals 4 minus x squared. Take the square root of both sides, and that's y equals plus or minus the square root of 4 minus x squared. When I put that into my calculator, I need to do both pieces to be able to get the plus or minus. So let me show you what that looks like. I'm going to go to my y equals. If there's anything in there, clear it out. I'm going to put the square root of 4 minus x squared, and let's go ahead and close that. You probably don't need to, but just to be on the safe side. And then the negative version, 4 minus x squared. And now I have the plus and minus, and we're going to graph that. And that'll give us the top and the bottom section of the circle. So that's what that looks like with radius of 2. I need to do the plus and minus to make that work. Okay, part B for today is about ellipses. And if I'm looking at ellipses with center 0, 0, I'm talking about A being greater than B. So A is the bigger side or the longer side of the ellipse. It's the one that kind of starts the ellipse. And that is x squared over a squared plus y squared over b squared equals to 1. And this is with center 0, 0. And so let's talk about some of the properties. If we're talking about the horizontal version, a horizontal ellipse, that would be one that would look like this, where the fat part is horizontal. The vertices then, So that's in the original form, x squared over a squared plus y squared over b squared equals 1. And your vertices are a comma 0 and negative a 0. So this would be a and negative a. A and negative a here comes from this number. Your covertices are 0 comma b and 0 negative b. That would be this piece and this piece. Those are my covertices, giving us how thin it is. And my foci, a foci is the distance from a certain point here, a fixed distance to your edge or to cause you to have the circle. So your foci is at C0 and negative C0. Your foci are inside of your vertices. If we're talking about a vertical ellipse, we're talking about one who hugs the y-axis. The longer part goes along the y. The formula for that is x squared over b squared plus y squared over a squared, because again the a is the bigger number. So if the bigger number is under x, it's horizontal. If it's under y, it's vertical. Your vertices, that equals 1. Your vertices then are 0 comma a and 0 negative a. Your covertices are b0 and negative b0. And your foci are 0c and 0 negative c. So it just kind of flips around from the horizontal. Let's look at a couple of examples how to do this. So example number 3. I want you to identify the conic as a circle or ellipse. So let's back up a second. Identify, is it a circle or an ellipse? Find the center, the vertices, the covertices, and the foci, or the radius as it applies, and I want you to sketch. So figure out what kind of shape it is, tell me the stuff that applies to it, and give me a sketch of it. Example number 3. If I have x squared over 4 plus y squared over 9 equal to 1. Okay, then I know that this is an ellipse, right? Because 4 and 9 are different. So it's an ellipse. The A is 9, that's the bigger one, so this is a vertical ellipse. So the center is at 0, 0. That's because there's nothing attached to the x and y. That's the only kind of ellipse we've talked about so far. The vertices are going to be 0, comma, and then the square root of this, so 3 and negative 3. The covertices are going to be this piece, 2, 0, and negative 2, 0. And the foci come from my C. Now, to find C, I'm going to use Pythagorean theorem. So I'm going to do 4 squared plus 9 squared equals C squared. And that already is squared, 9 and 4 because this is A squared and B squared. And that equals C squared. 4 and 9 make 13. And so C squared is the square root of that. Sorry, back up for a second. Where did that formula? Oh, okay, back up. I should have given you that way earlier. Let's flip back to the first side. And we want to include that to find C squared. We're going to do A squared minus B squared equals C squared. So it is not the Pythagorean theorem, but the idea does follow from it. I'll show you that at a later point, but that's the formula we're going to use. So let's come back over here and try to find our foci. A squared would be 9 minus B squared would be 4 equals C squared. And that's 5 equals C squared, or C equals the square root of 5. And so my foci coincide with my vertices, so that would be 0 square root of 5 and 0 negative square root of 5. Okay, and we have all the parts of our ellipse. Let's look at one more example. If I have x squared over 9 plus y squared over 9 equals 1. You'll notice that these two are the same, So I could multiply the whole thing by 9 and get x squared plus y squared equals 9, which lets me know that it's a circle with radius of 3 and center 0, 0. And if I want to sketch that, I'm going to start at 0, 0 and go out 3 each way. If I go back and sketch this ellipse, my vertices are at 0, 3, and 0, negative 3. My co-vertices are at negative 2 and 2. And my foci are at square root of 5, which is about 2.2, so that's here and here. And then I can go ahead and sketch that ellipse. Okay, and that was the end of today's lesson. You're doing A7, which is page 750. And you're going to do numbers 7 to 12. Good luck, and let me know if you have questions.